So you've seen these towers, but have you ever wondered what is at the end of the line? Joined here today with
James Watson.
So James, what is at the end of the line?
Well, at the end of a line, you will always find a substation.
And what is a substation?
Substations are very important facilities where we manipulate the flow of electricity around the national grid.
And what are the main components of this?
There are basically 4 key functions that take place within a substation, and they are switching, transformation, series compensation, and reactive compensation.
Shall we go and take a look at these and learn some more about them?
Indeed, let's do it.
What's the first function at a substation?
Well, the first function we're going to talk about is switching, and there are 2 elements to it. So there's switching from our control centre, but then there's also automatic switching. So we're standing in front of an air blast circuit breaker, and circuit breakers operate very, very quickly. This one in about 40 to 50 milliseconds. So we looked at the overhead line earlier. If that was to be struck by lightning, which does happen, British climate and all the rest of it, have a thunderstorm, it puts 500,000 volts on top of our overhead line, a lot of current flows. We have sensitive equipment that detects that and operates circuit breakers to clear the fault to make sure the lights stay on.
So we've looked at switching, James, and what's next? What are we looking at now?
Next we're going to talk about transformation, which is changing the voltage from a high voltage to a slightly less high voltage. So the electricity flows into this transformer from the supergrid. It's called the supergrid because it was superimposed on the original grid, but also because it's super. And it goes into the high voltage winding in this big tank behind me. And this transformer weighs about 200 tons. And out of the far side, you can see slightly smaller bushings. So we've got big bushings here. The bigger the voltage, the bigger the bushing. Big bushing, medium-sized bushing. Out of the other side, the slightly lower voltage of 132,000 volts. The electricity flows into the distribution network where it powers the local neighbourhood and beyond.
And why do we have it at different voltages from the transmission to the distribution?
That is an excellent question. We transmit over distance at the highest possible voltage because that minimises the current for the same amount of power, which then minimises the losses in the system. So it minimises wasted energy and it's more efficient that way. But what we can't do is bring big high voltages into people's homes because that would be dangerous. So at home you only need 230 volts. So the electricity from the energy source, as it travels around our grid system, goes through a number of stages of transformation before it finally reaches your sockets.
We've covered switching and transformers. What's next?
Well, next is what we call reactive compensation, which sounds like some sort of claim for money, but it's nothing to do with that. It's all about reactive power. So behind us is a capacitor bank, and this is used to control the system voltage. So the higher the voltage, the brighter your lights burn. The lower the voltage, the dimmer they go. You ever noticed at home when you flick the kettle on, the lights dim a little bit because you've just added a 3 kilowatt load to the system. It's called a voltage drop. This capacitor bank corrects that voltage drop. So when the volts are too low, this gets switched into service. It's not in service now because it's a lovely sunny day and we're not using a lot of electricity, so the volts are right where we want them to be.
So we're on to our fourth and final main function of the substation. Can you tell me what we're looking at here, James?
I can. We are looking at a quadrature booster, and a quad booster is part of a series of elements known as series compensation. So we talked about shunt reactive compensation with a capacitor bank. That's changing the voltage. What a quad booster does is change power flow into and out of the substation. If you imagine the national grid as a network of motorways and you're travelling around the country in your car and there's a traffic jam, you want to avoid that motorway because it's going to take too long, so you ask your sat-nav to find you an alternative route. We use quad boosters to force power flow around the entire country down the optimum routes to get the maximum capacity out of our system.
So next time you walk past one of these sites, you'll now know what goes on here and the vital role that they play in keeping your lights on and making sure electricity can flow into your home at a safe voltage.